You have killed the opponent. Right. Okay. So first off, we're going to catch you up because it's been a while since I've seen you, which has been fantastic. We're going to catch you up. Wonderful. On this thing. Stop it. This worksheet. Get it out. Worksheet from last week. It's been a while. No.
What is this?
This one says vectors and translations.
Is it this one?
Does it look like this?
Yes.
Then that's the one I want. If you don't have it, I can get you it.
I don't think I...
Kill the core.
Oh wait, I don't think I was it. Oh, I think this is it. I don't think I have it. I was gone one day. Maybe I turned it in.
Who else needs one? Ha ha.
Oh yeah. This one?
Yes. Anybody else need one?
Didn't we already do that?
All right. Snacks club. Are we good? Okay.
Wait, just kidding. I found it. This one?
We should do a snacks club. Yeah.
Here you go.
Yeah, because everything's due this Friday.
I'm sorry. So this is due this Friday?
Yes.
Okay. I'm lost.
Okay.
Wait, what's due Friday?
For the test.
No, next Friday. This Friday. Yes.
For the test. When is that retake?
I'm sorry?
When is the test like the retake?
What you do is you come meet with me, and once you're ready, then we decide when you need to retake it. Okay? But as soon as possible would be good.
That was. I never. Today's my last day.
Yes, it will. And we're going to talk about that today, too. Most of that we're not going to end up doing. You need to be excited. First of all, vectors. Right? We did this last time, but I'm just going to review it real quick because it's been a while. So just watch if you have it written down already, and if you don't have it written down already, also just watch and then copy it down at the end, okay? It's really what you should do. Okay, so are we ready? Do I have your attention? Wonderful. So, vector 3, 2, you can start it wherever you want. Last time we might have started at the origin. I don't know. We probably did.
We did this.
Okay, exactly, right. You can start it at the origin, but you don't have to. Okay? All a vector is it's saying we're taking a random point, any point you choose, and we're moving it 3 to the right and 2 up. So if I go from there, 3 to the right and 2 up, look, here's the vector. Ta-da. I can call it something like vector V. That's the symbol for vector. It's an arrow with only half the arrowhead. And there it is. We can also do another vector, 6, 4. Plot it over here somewhere. I don't know. Right? 6 to the right, 1, 2, 3, 4, 5, 6, and 4 up, 1, 2, 3, 4, 1, 2, 3, that's what I thought. Direction matters, so you need the arrowhead. I'm going to call it vector U. You probably have it different, because you started it at the origin. But you don't have to. You don't have to. Vectors can be anywhere, but they're always going to be the same. Just imagine copying and pasting it, right? Cool. I labeled them with their vector names. I called them what I wanted to. These are going to be parallel, as you can probably tell. We know they're parallel because their components have the same ratio. So the blue one is 3 over 2. And the red one is 6 over 4. And they equal each other. Therefore, these two guys are parallel. Cool? Awesome. Define the magnitude. Let's find the magnitude of the red one. 6, 4 are the components. Magnitude is size, yes.
I'm confused. Did you say those two are parallel?
Yes.
Okay. But like, are they on the same line or are they like this?
Even if they're, oh, remember you can put them wherever you want, so even if they overlap, you can move it somewhere else and it's parallel.
Oh, okay.
You see what I'm saying?
Yep.
Cool. Again, if they're going in the same direction, if they have equal components, the ratio of components is equal, then they're parallel. Okay? 6 over 4 is the same thing as 3 over 2. We cool with that? Cool. Awesome. All right, so to find the magnitude, we're talking about the size of the vector. So if I take 6 and 4 and square them and add them and root them, I get the magnitude of vector u. Okay? The reason for this is I want to know how long vector u is. So I break it down. Looks like 6 to the right and 4 up, right? So to find out how long this is, I do p-thag. Are we cool with that? That's the idea. I'm finding out how long the red vector is. That's what magnitude means. I know it's different than what you had written down. It's fine. The reason for that is because you can put your vectors wherever you want.
But my line's steeper, I think.
Is it? Well, it should be 6-4 according to this, right?
Wait.
Did you do 4-8?
This is what my line is. Yeah.
Yeah, well, 4-8's just a different one.
So 4-8 works? No?
So I'm reviewing this because we did this last time, and we can put our vectors wherever we want. So I chose these two vectors to graph, and I put the red one down here, just because I wanted to. Now, I might have randomly chosen the same spot as last time and done 4-8 there, but that was random.
I did 3-2 and 4-8.
Okay. Yes, you might have. So I chose to graph these two this time because I'm just reviewing it, and I put them wherever I want. I could have put it on the origin. I could have put it over here. I could have put it down here, but I chose randomly to start it there. The key is 6-4. Cool? All right. Awesome. So to figure out the length of this, I just do p-thag, right? 6 this way, 4 that way. Square them and add them, root them, and we get the distance between here and here. Turns out this is 52. Rooted. So that's the magnitude of vector u. Are we cool on finding magnitude?
Does it matter which one you do to find?
Well, you need to do it for all 4. I'm doing it for this one because I'm just reviewing this real quickly.
Okay.
Do we understand how to find magnitude? Awesome. Do we understand the ratio of components? And if they're equal, they're parallel? Carby, all right? You seem very concerned. These two are parallel because 3/2 is the same thing as 6/4. Cool with that? 3/2 is not the same thing as -1 over -2. So these two wouldn't be parallel if I was to graph them. I chose these two specifically so I could show you what parallel looks like. Okay? I'm just going through it fast. We did this last week. Okay? To find the magnitude, you good with that? p-thag, right? Cool. Awesome. Dig it. Yeah. Yeah, go get us all a drink. There's chocolate milk in the teacher's lounge fridge. All right, moving things by a vector. That's called translation. Turn the page.
Dude, I can't even see the fold. I get it. Colossal.
So, moving things by a vector is called translation. It's a slide, right? So we need to translate this by vector 5, 9, meaning we're going to go 5 to the right and 9 up. Okay? So we start on A and we move 5 to the right. 1, 2, 3, 4, 5. And then we move 9 up, which is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9. A prime. Ta-da! We do that for all 3 points and then we draw our triangle.
I did that right.
Wonderful.
I think I did too.
Next one.
Wait.
Next one. It says find the vector. So they gave you the translation already. Now, how do we know which way we're going?
That way.
We're going from A to A prime, right? And from B to B prime. And from C to C prime. So we're going that way. Now, what are those vectors? Well, they're all the same vector because it's just a slide. How do I figure out what the vector is? Well, I look at its components. Looks like we're going left 1, 2, 3, 4, 5. And we're going up 3.
Oh my god, I did it. Is that it?
Hell yeah.
Is that it?
We did it together in class last week. Do you understand where it comes from? I don't care about the right answer.
Wait, what about the top? What did you write for that? One more time.
What one more time?
Here?
Yeah, so it's 5 to the left and 3 up.
Okay. I got that.
Each one of those is 5 to the left and 3 up. Cool? Yes, Marissa. Okay, so we know that A is going to A prime, so there's the vector that does it, right? That's 5 to the left and 3 up. That's the components. Yep, that's all. I really like when you guys ask simple questions like that because, again, it's something this small that's causing a lot of confusion. So let me fix it for you, right? Thank you. Cocaine, not even once. All right. Turn the page. It says something about defining terms. Great. Use your notes. It's online, in color. Google Classroom. Bet. Draw a vector, it says. All right, cool. Let's draw a vector. Do you want to do it from the origin or place it randomly? On the origin. Awesome. All right, I'm going to put a dot there. I'm going to put another dot randomly. How about here? I'm daring. We're making our own vector. Make your own frickin' vector. There it is. Call it something. I'm going to call it vector D for dumb. Okay? You call it what you want.
Becky.
There you go. Vector B for Becky. So I know that its components for this guy is going to be 3 to the right and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 up. So there's my vector. 310 is my vector. Its vertical and horizontal components are there. Now we need to find the magnitude. Magnitude is Pythag. 3 to the right, 10 up. Well, that's 3 squared plus 10 squared. All rooted is the magnitude, right? So my vector has a magnitude of 109. What does your vector have a magnitude of? Root 109, I should say.
Minus 2.
What?
What's the thing on top of the thing?
This right here? That's the symbol for vector. It's an arrow with only half the arrowhead. And I called it vector D for vector dumb. You can call it whatever you want. Like she called it vector B for Becky. You can call it V for vector or V for Becky.
You know.
Mine is D for Decky. Hers is B for Becky. Mark's is vector M for Mecky. M is in Mancy. Great show. Any of you guys watch Archer? Archer. Not Arthur. Of course we watch Arthur.
I watched Arthur.
Archer.
Is that like? I feel like I've watched it.
It's a very funny show. Make your own.
I tried to make my own, but I did it wrong.
You can't.
I did. Don't even say you can't do it because I did.
Dear God.
Because I have already not been good.
Please help these dumb
I
kids.
got 2/3 or something like
Please help these dumb kids. All right. Now look at the geometry reflections worksheet. Get it out.
that. What?
Do it.
Do we turn this in or no?
Let's do Friday. Why? Why? Good.
Yeah, I'm gonna
Game Club. I'm there. Only if you're ready.
I know, it's fine.
But yes, if you review tomorrow and you knock it out of the park, yeah, of course. Sure. Rylan.
Yeah. Is it 89 a B flat?
That's too technical.
Like, you know how you say 3 flat? So it's like exactly 3. What?
I know what you mean.
3 flat.
I know what you mean. Not music.
Swimming, Andrew. If you say 3 flat, you get exactly 3 minutes.
So, this one. Remember we used the reflection tools to reflect the thingies, right?
This was.
Turn the page. Look at number 3. We did it together already. So we did it together, which means everybody stop writing stuff down and just watch me do it again so you know what's going on. It's been a while, okay?
This one, right?
Yeah.
Okay. Yes. I need lotion.
So we're going to flip this point across this line. Well, here's the point. 1, 2, 3, 4, 5, up 3. Let's call it A. The line that we're going to flip it over is y equals x. How do we graph y equals x? Well, what's the y-intercept? Try again. 0, right? Because another way to write this is like this. Yeah, don't do that. Think. So the y-intercept here is 0. Do we agree? Okay, so it hits 0. And it has a slope of up 1 over 1. So I go up 1 over 1, and I keep doing this, right? Awesome. So that's my line of reflection. I hate this protractor because I can't ever lift it up. We take out Saddam. Veronica is a great ruler name. Veronica is all of us. All right. So there's our line of reflection. Here's how reflections work. When I look in the mirror, okay, the distance between me and the mirror is the same as the distance between me and mirror me. As I move closer, mirror me moves closer. As I move further away, mirror me moves further away. So the idea is that this point right here is going to reflect across this line the same distance as it was before, right? And it's also going to be on a line that's perpendicular to our line of reflection. So here's what we're going to do. We're going to find the perpendicular line that goes through that point. This is what we did on our last quiz. So I'm going to find the perpendicular line that goes through point A. So here is my line. It's going to be y equals, if the slope here is 1, what's my perpendicular slope going to be? -1. Flip and change it, right? To figure out b, I know that it has to go through this point, right? So I'm going to take that point. I'm going to plug it in for x and y to see what b has to be, so that when I plug in 5, I get 3. Cool? You aren't writing, you're watching. So there is our perpendicular line. Ta-da! There's the perpendicular line. Right? So now I'm going to graph that line. Positive 8 for the y-intercept. 2, 4, 6, 8. Slope of down 1 over 1. Oh, look, it does go through that point. I didn't screw up my math. Something like this. All right, so there's the line that's perpendicular to that one and goes through point A. So we know that when A gets reflected, it's going to be on that line somewhere, okay? It's going to be the same distance from here to here. So we can probably eyeball and say there's where A prime's going to end up, right? Same distance on both sides. Now, we're not going to do that because looks can be deceiving. We're going to do algebra. Again, algebra hard, math easy, or geometry easy, right? So here's what we're going to do. We need to figure out where do these two lines intersect. Again, we're not going to just use our eyeballs because we could, right? We're going to do algebra to figure out where they intersect. How do I figure out where two lines intersect? That's right, but we're not going to do that. But we're not going to do that. Yeah, given their equations, how do you find out where they intersect?
If you do the x to...
We're going to do that, but not yet. So, we're going to find out where the two lines intersect by setting them equal to each other, right? If y equals this guy, right? If y equals this, and y equals that, don't these two equal each other?
Wait, can you say that slower?
Yeah. If y equals this, and y equals that, don't these two equal each other? Where they equal is where they intersect. It's where they agree. So we're going to take the red equation, x, right, and set it equal to the blue equation, negative x plus 8. And where we get an answer for x is going to be the x coordinate of where they intersect. Yes.
Why isn't it 1? Oh, wait, okay.
Because it's the same thing as x. Yep, good question.
I get it.
Nope, good question. Does everybody see that this right here is the same thing as just x? so I just wrote x. So I'm going to add x to this side, and I get 2x equals 8, which then means x equals 4. So our coordinate where they intersect is going to be 4 comma something. How do I figure out the something? Yeah, plug it in. Well, if I plug it in, I get 4 equals y. So when I plug in 4, I get 4 for y. So where they intersect is going to be 4, 4. It is. Oh my God! All right. So A was our original point at 5, 3. M is the midpoint at 4, 4. Let's go find A prime. A prime is the same distance on each side of the line of reflection, right? So this distance here is the same as that distance there. In other words, this point in the middle is the midpoint, so we can use midpoint formula to find A prime. Ringing a bell? So we know A is at 5, 3. We know M is at 4, 4, and we're looking for A prime. What is the midpoint formula? Nope, that's not how we say it. That's right, average of the x's, average of the y's. We're looking for the average point, right? The midpoint. How do we average stuff? Do we add or subtract? You add them all up and divide by the number of pieces. So it's going to be this, right? We know M is 4, 4, right? And we know one of our coordinates is 5, 3. Are you watching? Good. So now we're going to solve. We know that this part here should equal that. X plus 5 over 2 equals 4. Let's do it in our heads. Times by 2 to get rid of the divides by 2. What's times 2 over here? 8. Subtract 5. So x is 3, which means our point that we're looking for is 3 comma something, right? We also know that this bit here should equal 4. Times by 2 and subtract 3. So A prime is at 3 comma 5. And look, it is. And there's your answer. I showed you algebraically, because eventually we're not going to have the graph at all. And I'm going to say flip this point across this line, and you're going to have to pop that out. Okay? Here's what we did, because it seems like a lot. If you mark every step, hi Mark, it'll be a lot of steps. So we're not going to do that. We're going to talk in concepts. What do we do here? I graphed the original line. That's the red one. I then found the perpendicular line. Right? Flip the slope, plug in the thing. I graphed it. I found where they intersected by setting them equal to each other. Then after that, I took that point as the midpoint and did midpoint formula to find out where the flipped point is going to be. So again, graph this line, graph that line. See where they intersect, do midpoint formula with it. Graph the red line, graph the blue line, figure out what the equation is, graph it. Set these two equal to each other to see where they intersect. Take that point and do midpoint formula with it. If I have you at about 50, that's pretty good.
Wait,
Okay?
wait, did we do this together or did I actually like?
We did it together. We're in like different time zones, my friend.
I can't even remember half the things I did yesterday.
I know. But swim's over, right?
What?
But swim is over, right?
For me, because I don't want to do it. It's
Gotcha.
basketball.
Okay. You're in basketball?
I'm-
Really? Really?
I suck.
I'll go to a game. I'll cheer you on.
You probably shouldn't.
Be like, go Bailey on the bench. Woo! Cheer on your teammates.
No, she just gets. I have anger issues. Yeah, she gets really angry, and then she gets taken out. So her anger issues. I have a coach girls basketball who text each other around the entire time. Yeah, she has like 4 technicals.
All right, next one.
I fell out of every game now, so she couldn't play anymore.
What's wrong with you guys?
Girl shoved me into the wall. I broke a girl's arm. We didn't ask.
That's cool.
I went for a layup and the girl was chasing her and jumped up and blocked her, but she like kept going. She fell.
And the girl was screaming in pain and everyone ran to her, but the game was still in play and then I scored.
I was a part of 2 girls' basketball championships while I was in college, and I say I was a part of it because I was hired. I was paid to distract the other team. And I was good at it. I was real good. And number 7, right? I mean, I was just amazing, okay? Their free throw percentage was like negative when I was there, okay? I was amazing. I almost got kicked out multiple times. 2-time champions.
I want to do that.
I'm a big deal, okay? And then when I wasn't distracted, I played drum set in front of this band that was gigantic, and it was just like, I just do what I want, right? I got paid good money to play drum set and distract people. And the drum set part was actually just as cool as distracting people. Like, oh my God, it was just blowing people's minds. All right, anyway. So, this guy, here's what we're going to do. We're going to graph the original line. We're going to plot our original point. So far, so good, right? Plot 2-1. Done. Call it A.
Oh, whoa. I already have a point.
Yeah, me too.
Wow, magic. I don't have an A though. There.
I know you don't. There's a reason for that. All right. Graph this line. Graph this line. Y-intercept at -2. Don't hurt me, Bailey. -2, 3.
Wait.
Give you a technical.
Oh yeah, I did it wrong.
Oh, wait,
I can't even see the
I
board.
have 2 of the 3 dots right.
wait, 2, 3. How did you find that?
-2 y-intercept.
Yeah.
Then down 2/3 for the slope.
Did you say don't get a technical?
No, but we're once again in different time zones. All right. So now we're going to draw the line that's perpendicular to that and goes through point A. So our original equation had -2/3 slope. So our perpendicular line is going to have what slope?
Negative.
Try again. Change the sign.
3/2.
Yep. Change the sign and flip it. Then we're going to plug in the point that it goes through, which is A. A's coordinates are here. So we're going to plug in 2-1. Veronica deserves better. That was good. 3 divided by 2 times 2 is what's going on here. So we can times by the top or divide by the bottom first. What do you want to do? Times by the top, you coward. Divide by the bottom. Let's do it. What's 2 divided by 2? 1 times by the top now. 3. Now, Bailey, if you had times by the top like the coward you are, you would have done 3 times 2 and got 6, and then divide by 2 and got 3 still.
Of course. Yep.
Subtract 3, and we get -2 is B. So our equation is y equals 3/2 x minus 2. That's the perpendicular line. How do you graph something like that? Well, y-intercept is what? Ooh, look, it's that same point. And then up 3/2. Oh, look, it's that same point. There it is. How did I graph the red line? I went to -2 because that's the y-intercept. And then I went up 3/2. If you were confused and you're trying to write stuff down and you're like, he's going too quickly, here's what you need to do. Stop writing stuff down!
No, because I look at it.
I know. But you can look at it after. I'll give you time to copy it down. Stop writing. I swear you'll do better. I swear. That's my girl. What?
Do you have super glue?
No.
When do your glasses get fixed? Like when are they?
I'm getting them today.
Do you have contacts?
Really?
No.
I don't either.
That's what's been going on? You know, your glasses are broken and you're not wearing them, you don't have contacts.
I have contacts, but I don't
My
like
glasses
Child.
are not broken, but I'm not wearing them.
I have something in my shoe, but it's breaking. My shoe is breaking, and they said it would last me, and it's not. So I might say.
All right, so stop writing. Watch. Here's what I did. No writing. Try it. Look. Diana, let's be honest. Has the writing done any good for you so far? No, it hasn't. So let's try something new. The worst that could happen is you get the same grade, right? Okay, so here we are. I graphed the original line. Eyes. Thank you. -2 is our y-intercept. There it is. Down 2 over 3. That's our next point. There's the line. Blue line, we good?
Oh, so you go down 2 over 3.
Yeah. See how much you learn by just watching? All right, so now we have perpendicular slope. Flip and change the sign, right? See how it was this and now it's that? Good. We're going to find out what b is by plugging in the point. We found b. It's -2. So here's the equation. I graph it. -2 for the y-intercept. Oh, convenient. It's the same dot as before. Up 3 over 2. Ah, it's the same point. Oh, man. Draw your line. So far, so good? You get it. And it took me like 15 seconds to explain it. Amazing! Again, I'm just some guy. What do I know? But here's my thought. Notes are stupid. You don't look at them anyway. You don't know how to study. Right? Let's be honest. You're not going to look at them. You're not going to. But if you do, here's your time to copy it down. Right? After you learn it. I need to write this down so I can remember it. No, you learn first, then you memorize second.
I don't think they'll let me do that in college.
They will. They'll give you the slides. Here's the PowerPoints for the year. Here's your code to get into the Dropbox. What is the point of college? To get a degree. To learn what you need to do to get a job. How do we learn most effectively? Not writing crap down. So will you be ready for college? Yes, you will, because you're going to learn how to learn. Now.
Visual learners and some people are
Exactly.
learners.
I'm a visual learner.
Writing learners.
What kind of a learner are you?
I don't know.
Guess what? Everybody's all of those things. It's just in varying amounts. It's a spectrum. Everyone is a certain amount of visual learner. In fact, visual is really good because it allows us to see what's going on, right? Now, if you're not a visual learner, close your eyes and learn the rest of class. Yeah, good luck, right? So watch and then copy crap down. Because then you'll know what it means. Try it. Just try it. So, we're here. We need to find out where these two intersect. Now, I can see where they intersect, but let's do algebra so we can do it without having to look, right? Because that's you guys. You don't want to look. You just want to do this, right? So here we go. How do I figure out where two lines intersect? I take their two equations. I need you up here. Bailey. We're going to find out where these both intersect by setting them equal to each other, right? If that equals y and that equals y, don't they equal each other? So I'm going to write that out. The blue equation was -2/3 x minus 2, and that's going to equal 3/2 x minus 2. Now check it out. When I add 2 to this side, it goes away, right? Because adding 2 gets rid of -2. Are you watching? Good. Then you'll get this. -2/3 x equals 3/2 x. How did I get there? I added 2 to both sides, and it went away. Now check it out. I'm going to try and combine these two x's. I need common denominators. But if you're clever, you know the answer. Something times x should equal something times x. It's got to be 0. It has to be. But let's pretend you don't know that. I'm going to add 2/3 x. That's 0 on this side. 2/3 x on this side. Let's get common denominators. Both over 6. What did I do to the 2 to make it a 6? So I times the top by 3. 9/6 is the same thing as 3/2. We agree? I didn't change the problem. I just looked at it in a different way. It's helpful to look at it this way because now I can combine these guys. 3 times 2 is 6, so 2 times 2 is 4. So how many 6 do I have total? 13/6.
So how did you get 9 and 4?
I got 9 and 4 because I multiplied the 2 by 3 to get 6, so I multiplied the 3 by 3 to get 9. 2 times 3 is 6. 3 times 3 is 9. I multiplied this guy by 3 over 3. Why am I allowed to do that? Because 3 over 3 is 1. So multiplying by 3 over 3 doesn't change the problem. It just makes it look different. And if I multiply this side by 3 over 3, I'm sorry, not 3 over 3, 2 over 2, I get 6's on the bottom and 4 on top. Cool. Again, both are legal because it's just multiplying by 1. That's what common denominators is, okay? So trust me on that if you're only 50% on how I did that, okay? Just trust me on that for now. That's not the heart of what we're doing here. So I have this now. Something times x is 0. Again, you could do math and multiply this side by 6 and then divide by 13, and you get 0 equals x. But think about it. Something times x is 0, right? Or sorry, let me say it differently. 13 over 6 times x is 0. What does x have to be? Something times 0 is 0, right? So x is 0. So they intersect at 0 comma something. I'm going to figure out what the other part is. When I plug in 0 here, what's 3 halves times 0? Minus 2. Negative 2. So they intersect at 0, negative 2. Oh, look, they do. Okay? So that's our midpoint. What's midpoint formula? That's what I'm talking about. Midpoint is average of the x's. We add and divide by the number of pieces, right? That's what average means. Average of the y's. Our midpoint is 0, negative 2. We just found it. We know one of our x's and we know one of our y's. The x and y that we know is the one that was given to us, 2, 1. That's this point. We're going to find the other point that's flipped. Okay? That's these guys. The x and the y that got flipped are these guys. The x and the y that we know is 2, 1. I'm going to say that again. This point right here is 2, 1. That's the point we know. The point we don't know is where it flips to. That's why we left it x and y. The midpoint we just found. Are you cool? No? Everybody agree with the midpoint? We just found that. Where the two lines intersect is the midpoint. Where the two lines intersect is the midpoint. A is going to flip somewhere over here. I'm trying to figure out where it flips to. I know A is at 2, 1, and I know where it flips to is going to be the midpoint, or halfway between this and the midpoint. So that's going to be our x, y. So we're looking for x and we're looking for y now, okay? 2 and 1 comes from A, which they gave us. 0, negative 2 comes from the midpoint, which we found, where the two lines intersect. This right here should equal that. This guy right here should equal this guy right here. Let's do the math in our head. We're trying to get x on its own. So we need to multiply by 2, right? What's 0 times 2? 0. And we need to subtract 2. Negative 2. I multiplied by 2 and subtracted 2. I got negative 2. Over here, I know this should equal this. Multiply by 2. Negative 4. Subtract 1. So that's where A prime is, our reflected point. Negative 2, negative 5. Here's what we did in slow-mo. Don't write it down yet. Now is not the time to write it down. In slow-mo, here's what we did. I graphed the original equation. Remember how to do that? Slope, y-intercept. Right. I took my equation and made it perpendicular. Solved for b. Graphed it. Then I found where they intersected. How did I do that? I set them equal to each other. And I solved. I got 0. 0 for x. I plugged 0 back in and got negative 2 for y. I took that point, which is this point right here, the midpoint, and I said, look, if I know what A is and I know what the midpoint is, I can figure out what A prime has to be using midpoint formula. Midpoint is 0, negative 2. A is 2, 1. A prime is what I don't know. I solve for x and y, and there's A prime. Did you follow me as I went along? Do you feel about 50% good? Okay, I'll take 50. Here's what I'm going to do now. To show you that it's not that many steps, I'm going to go through it a little bit faster. By faster, I don't mean I'm going to talk faster. I mean, I'm going to skip over some of the explanation. I'm going to talk in concepts, not steps, okay? Not yet. Here are the concepts. I graphed my first line, and I found the perpendicular. I know that A is halfway between, or I'm sorry, that A gets flipped over M, the same amount on each side. So after I found M where they intersect, I did midpoint formula to find where A prime is. So find the perpendicular and then do midpoint. Find the perpendicular and then do midpoint. That's all we're doing. You know midpoint formula. Average of the x's, average of the y's. Here's my midpoint. Here's the point they gave me. Solve for the other one. You know how to find the perpendicular. Flip the slope and change the sign. You can do this. If you want to write this down, you can write this down now. How you feel? Better? You wrote it down? Good. Yeah. Did you feel like the not writing helped or no? Yeah. Isn't that cool? Less work for better results.
But I still like it right back.
I understand. No, I get you. I get you. Like, honestly, if you want this copy after I'm done, I'm just throwing it in the trash anyway. All right? For the homework, everything's made up and the points don't matter. They don't. I want you to learn. Okay? We're skipping number 5. You guys didn't have algebra with me, so I'm not going to attempt number 5 with you guys. There's an easy way to graph it, and there's a hard way to graph it, and I'd have to teach you the hard way because I never taught you the easy way. I'd have to do it the hard way because that's how we learned it. I teach you the easy way, right? Nothing wrong with that. I just don't know like what you have, and that's not fair. This one, it's the same thing we did before, except now they're giving us the image and saying find the line that it flipped over. Before they gave us the line and they said flip it, right? Now they're saying I already flipped it. What did I flip it over? Find the line. So here's what we're going to do. We're going to find the midpoint between these two guys and the midpoint between these two guys. And their midpoints are going to make our line of reflection. Right? Oh no. That wasn't a, I got it.
It's mine anyway.
Okay. How do we find the midpoint? How do we find the midpoint? Average of the x's, average of the y's. So from A to A prime is what happened. We're going to write the coordinates and find the average of them, right? That's going to be our midpoint for A to A prime. We're going to do the same thing for B or C. Let's do B. Coordinates of A, negative 1, 2, 3, 4, up 1, 2, 3, 4, 5, 6. And A prime is 6, negative 4. B's coordinates, 2, 4, 6, 8 to the left, and 4 up. B prime's coordinates, 4, negative 8. Write that down, write that down, write that down, so we can move on. Or don't write it down, and write it down later, I don't care. But if you're going to write it down now, get it done. No, it's not minus because we're averaging. It's adding. Bailey, this is why you need to stop trying to memorize it that way and think about the concept. Average of the x's, average of the y's. You'd never say averages, subtract them. We have other formulas that are minuses, which is why you're going to get them confused. Yes, it's adding for midpoint. Why'd you write a minus? It's not. It's averaging. In average, we add and then divide by the number of pieces, right? That's how you need to think of it, because then you'll never forget. So we're going to do midpoint. Average the x's and right? It means to add them up and divide by 2. So we're adding 6 and negative 4. What do we get? 2. Now divide by 2. 1. Now average the y's. 6 plus negative 4 is 2. Divide by 2, you get 1. I'll see you guys tomorrow. We're going to work more on this. Have a moron day. Most of your quiz on Friday will be, half of it will be translations, which we like, vectors, right? And half will be reflections. Okay? Go away. you like this?